Hi everybody, Miss Marsh here. This is a video that's going to be about operations with rational expressions. Essentially what we're going to do is we're going to be able to add and subtract rational expressions, multiply and divide rational expressions, but also be able to find the least common denominator when we're adding and subtracting. So this is for days 15 and 16, so you may have already started it for Opt 2. Okay, but we're going to go through all 4 operations, and also there's going to be some notes that have lots and lots of examples available to you as well. Okay, to begin with, let's just take a moment to review how to add, subtract, multiply, and divide fractions, because essentially rational expressions are just fractions with polynomials. So you may recall when you're adding and subtracting, you need a common denominator. So for number 1, we have 1/2 plus 1/3. We need a common denominator in order to add these fractions. The common denominator is going to be, the lowest common denominator is going to be the smallest number that 2 and 3 are factors of. So we want to think of a number that 2 goes into evenly and that 3 goes into evenly, so that we can easily make a common denominator. And if in doubt, you can just multiply 2 times 3 and you'll get a common denominator. In fact, this is the lowest common denominator, 6. It is the smallest thing that both 2 and 3 go into. So what do we do to get them to be 6? We need to multiply by fancy ones. So if I have a half and I want it to become something with a 6, I need to multiply the denominator by 3. But I cannot just multiply the denominator by 3. That is not really allowed, but I can multiply by 3 over 3, because 3 divided by 3 is just 1, and multiplying by 1 does not change its value. So that gives me 3/6. This is the equivalent fraction to a half. And then we have this third. I'm going to multiply by 2 over 2, which is just a fancy version of a 1, so that it becomes 2 over 6. Now they're both like denominators. So I have 3/6 and 2/6, which gives me 5/6. Subtraction is the same way. We would have the same common denominator, and it's still 1/2 and 1/3, so it would be 3/6 minus 2/6. The only difference is we're subtracting, and that gives me 1/6. For multiplying and dividing, multiplication, if possible, you can cross cancel, but if not, you just multiply across. So 1 times 1 is 1, 2 times 3 is 6. So for multiplication, we just multiply across. For 1/2 divided by 1/3, you may remember something called keep, change, flip. Keep the first one the same, change the division to multiplication, flip the 1/3, and now we are dealing with a multiplication problem. So 1 times 3 is 3, 2 times 1 is 2, and there's our answer. Okay, so these are the notes that I'm going to provide for you. You can add them to your own notes or do it, or just read through them however you want to use them. So for multiplying with rational expressions, the first important step is we are going to need to factor the numerator and the denominator of everything involved so that we can look for things to cancel. Okay, and I'll show you some examples. We can cross cancel, and we can also just, anytime you have a common factor in the numerator and the denominator, you can cancel it. And then if there's anything remaining, you're going to multiply across. All right, so let's go to your book. Specifically, we're going to go to page 438 and look at number 6. I am doing the lesson out of order. We're going to start kind of at near the last half with the multiplication and division first, and then we'll go back and do the addition and subtraction. Okay, so let's look at some of these multiplication problems. Now, the first thing I said to do was factor, right? But sometimes factoring doesn't really make sense. Like in 6a, when we just have monomials, so one-term polynomials, in all four parts here. For this, we can just cross-cancel and reduce and things like that. So let's see what we have here. We have numbers, we have variables, specifically we have A's, we have B's, we have C's. Okay, I am going to, there's a bunch of stuff here that's going to cancel. First of all, I see the A's. There's an A here and an A here. They are one on the top, one on the bottom. We can just cancel them. Okay, then we have C's. I have one C on the bottom left and C squared, which is essentially C times C in the top right. So one of the C's are going to cancel, but there's still going to be an extra C left over. Same thing's going to happen with the B's. B squared is B times B. So one of the B's are going to cancel with one of the B's. Okay, so then now let's look at the numbers. I see 2 right here, and 2 will go into 4 twice. And 3, this 3, will go into itself once, and it'll go into 27 9 times. So keep in mind the B squared I rewrote as B times B, so that's kind of gone, C squared. So what do we have left? I'm gonna get a highlighter here so we can see what we have left. In the numerator, I have one B left and one C. In the denominator, I have a 2 and a 9. That's it. So multiplying across, I have in my numerator B times C, or BC. And in the denominator, I have 2 times 9, which is 18. So this is an example where you don't need to factor because they're monomials. So let's look at a case where we do have binomials and monomials, okay? With the binomials and above, you want to see if you can factor. So I see 5x minus 15 has a GCF. We are going to have to fix that immediately. Okay, so this 5x minus 15, I'm going to take out the 5, and it's going to be left with x minus 3. Now that I've written it that way, I can start to see the factors that I can cancel. Okay, so for example, let's see, I have an x minus 3 and an x minus 3. Okay, the x minus 3's on the top is going to cancel with this x minus 3 in the denominator. All right, what else can I do? I have a 3x in the top left and a 9x squared. So 3 definitely is going to go into 9 with a 3 left over here. And x squared is x times x. So essentially it's going to reduce your exponent, right? Because we can write x squared as x times x. And then you can see that x and one of the x's cancel. And then I think that's it. So looking at what I have remaining here, there's nothing left in the numerator. And so if there's nothing left in the numerator, you need to put some 1s there. So you know that there's at least a 1 in the numerator. And then our denominator, we have a 5 left and a 3 and an x. I can multiply the 5 times 3 to give me 15. And I have an x. All right, let's go ahead and look at C. C has a couple things that I can factor. I can definitely factor the trinomial here, or I can at least try and factor this trinomial here of x squared minus 4x plus 3. And then I also see 4x plus 20 has a GCF of 4. Okay, the x plus 5 and the x minus 3 are not going to be, you can't do anything with those. But let's start with the x squared minus 4x plus 3. I'm looking for two numbers that multiply to make 3 and add to be negative 4. So multiply to make 3 and add to make -4 are -3 and -1. All right, so that's going to replace this. I basically just kind of cross it out so I don't have to rewrite the whole thing. And I have rewrite it as x minus 3 times x minus 1. And then over here, the 4x plus 20, I can take the 4 out, and I'm going to be left with x plus 5. And I think that's all that I can factor. So now I get to the fun part, which is to do the cancellation. All right, so I see I can cancel an x minus 3 here and here. And I can cancel an x plus 5 here and here. So once again, my numerators are completely canceled out, so I do need to remember that there's a 1 there. Okay, in the denominator, I'm left with a 4 and an x minus 1. You can write it as a 4 times x minus 1. You could actually multiply that in and make it 4x minus 4, but it's not necessary. You can leave it in factored form. All right, and then our last example has 3 fractions that are multiplying. So the first thing I want to do is I want to factor everything I can possibly do so that I can look for those parts that I can cancel. All right, so I'm noticing a GCF. I can see some trinomials here that I might be able to take some stuff out, and that. So all 4 of those things I can see that I need to factor. The 3x squared is a monomial, so you can't factor that, and x plus 5 is nothing to do with that. So let's start with the 7x minus 7. There is a GCF of 7, so I'm going to take it out, and I'm going to be left with x minus 1. 9x squared minus 9 has a GCF of 9. And then I notice that I have a difference of squares. X squared minus 1, so we're going to go 2 steps here, is going to become x plus 1 times x minus 1. Okay, so I just want to look at the completely factored version, so I'm just going to cross those other ones out so I don't look at those. X squared minus 5x minus 6, we can find 2 numbers that multiply to make 6 and add to make -5. That would be -6 and 1. So x minus 6 times x plus 1. Cross this out so I don't look at that anymore. And then the last one, we have a GCF of x. And then I think I'm going to have to do a little bit more factoring with this. So I'm going to take out one of the x's. And this is a trinomial where I could see 2 numbers that multiply to make 5 and add to make 6 are 5 and 1. So x plus 5 times x plus 1, and I'm going to cross these out again because I just want to look at the factored version. If you want, if this becomes too complicated, you can just rewrite the whole thing. So I think I'm going to do that for this one. All right, so I rewrote it. Now we get to the fun part where we get to cancel everything that we see. So remember, you're just looking for anything in the numerators that can cancel with anything in the denominators. All right, so I see x plus 5, gone. I see an x plus 1, gone. I see an x minus 1, gone. And I think that's it. So in the numerator, I am left with an x minus 6 still there. In the denominator, I've got some stuff I need to multiply. I've got a 9 times a 3 and an x squared times an x and an x plus 1. So 9 times 3 is 27. X squared times the x gives me x cubed. And then I have an x plus 1. And I don't really need to multiply this out, but I could distribute that. All right, so that's how we multiply. About division. So let's go ahead and look back at those notes and let's talk about division. With dividing fractions, you just got to do the keep chain thing, okay? Change the division to multiplication, take the reciprocal of the second fraction, and factor and multiply. You could you're still going to have to factor. You could factor first and then do the keep change flip, or you can do the keep change flip, then do the factoring. You can do them at the same time if you're feeling fancy. And then this little picture I just want to show you. This is just a joke on the internet. No one's killing kittens, I promise. I love cats. I would never. But it's just a silly thing to remind you that this type of canceling that you see in this example is not allowed. You cannot cancel unless it's in factored form and things are multiplying. This is a big no. Don't do it. Okay? Anyways, so we're going to look at some division problems in your book. Okay, so I'm looking at number 2, which is pretty much page 440. Okay, so to begin with, we're going to start with one that is monomials only. And so we want to, let's start by just rewriting it. I'm going to keep the first one exactly the same, 9ab squared over 4c. Change the division to multiplication. And then flip the second fraction. So we're going to have 5ab on top and 18c squared on the bottom. And then we're going to look for things to cancel. All right, well, I'm looking at the variables here, and the a's are all on top, the b's are all on top, and the c's are all on bottom. So our a, b's, and c's are not going to cancel at all. But I can cancel one thing, and that is 9 goes into 18 twice. That's all. So now I just have to multiply across. I'm going to put my numbers in front, so the only number I have is a 5. And then I'll do the a's. A times a is a squared. And then I'll do the b's. B squared times b is b cubed. And then the denominator, I'm going to do 4 times 2, which is 8. And c times c squared, which is c cubed. Not a lot of canceling in this one, but that doesn't always happen. Okay, let's look at b. So here we got something a little bit more complicated, and I can see there's going to be some factoring. So first, I think I'll just do keep change flip. Keep the first one the same. Multiply instead of divide, and flip the second one. Then it just becomes a multiplication problem. At this point, I'm going to see if I can factor some things. I see 3x squared minus 27 and 3x minus 9 can be factored. Okay, so I'm just going to focus on the factoring. I'm going to take a GCF out, 3, and then x squared minus 9. Oh, that is a difference of squares, so that's going to be 3 times x minus 3 times x plus 3. Okay. So let me write that. Move it up. Okay, and then for the second fraction, we have 3x minus 9, which we can take a GCF of 3 out, and that would leave us with 3 times x minus 3, all over 4x squared. Okay, let's do some canceling. So I see a 3 and an x minus 3. Gone. I also see an x squared and another x squared. They're exactly the same. They're gone. Multiplying across, the only thing I have left in the numerator is a 7. In the denominator, I have a 4 times x plus 3. All right. There's one more. Why don't you guys try this one on your own? Okay, so go ahead and pause it. Try C on your own, and when you're ready, you can unpause it and see how you did. Okay, I didn't quite finish it yet, but I did do the first 2 steps, which is to keep change flip. We rewrite it, and then I factored. So I'm left with 3x times x plus 5 divided by x minus 8 times x plus 5 times x plus 8 over x minus 8 divided by 5x squared. All right, so I see x plus 5s are going to cancel. We have an x minus 8 that's going to cancel. And then we have an x, which will cancel with one of the x's here, but you're going to be still left with one extra x because there's an x squared. And then going across, we've got on the top, we've got a 3 times an x plus 8. And in the denominator, we just have 5x. And that's the answer to that one. Okay. So this is multiplication and division. I think I'm going to have to do a part 2 where we'll do the addition and subtraction. So stay tuned for part 2.